Before we get started with the class, this meeting is being recorded. Just want to do a quick check of the folks who had attended the last class. So can you just drop or react for me to get an understanding of all the people who had attended the last class? Just like drop a message or let me know that. Uh, okay, I can see some hands. Okay. Anirudh, Manichand, Rahul. Rahul is saying Sui in the chat for some reason. Truti. Okay, I think Kavan was there. I had seen his message. I think Dalil was also there. Alice was there. Okay, Suleka was there. Okay, perfect. Um, got it. Okay, awesome. Um, all right, folks. Before I get started, then on this class, I just want to do a very quick revision for the last class for the people who had not come. Otherwise, the things we'll start with today would not make sense. So basically, in the last class, we studied a little bit around creating our own structures in MoveLang, and we are now building on to actually going on to resources. So if you had attended the first class, you would remember that I discussed that resources are special type of structs. These are special type of structs that cannot be copied or dropped. Okay, and for the other normal structs, we have four capabilities or abilities that we are talking in Move: copy, drop, key, and store. Okay, so copy is for duplication, drop is for removing, and key and store work together as like a key value pair. Okay, so here we had created this fellow struct, basically talking about this Aptos fellowship program that we have, and all of us being fellows here. And here we had, sorry for that, yeah. And here we had mentioned this, like the struct fellow, which has drop. There was a reason that we had added this drop later on. Does anyone want to share why this drop was added in this particular struct? Why the struct was given the capability of drop? So the reason why I'm actually grilling you folks on these things is because if we start going deeper and these topics don't make sense, then it would be difficult for us to, yeah, right. So as Alice has mentioned, the reason why this drop has been added here was to clear the memory, because whenever we are defining in our test script, we had, yeah, over here. So we had described this new fellow, okay, and whenever we are trying to like show certain things, for example here we are showing the FID thing, right? So we have to make sure that all of the like all of the things attributes mentioned in this struct, and by the way this struct can have like other struct itself as its fields as well. All of them can be dropped, all of them can have the like memory basically needs to be cleared before we move to the next step. It's like garbage collection sort of for move lang that we have to do, because this is what we are doing here, that we are like creating a new fellow and then we're trying to read certain information. In this case we are getting the id f.id. So before this function ends, this we need to ensure that this particular variable can be cleared of the memory, or it needs to be consumed before this function is ending. This is like a necessary factor here. That is why we have this has drop over here. If you remove this drop and try this particular test code, it would not work. It will give you an error that will tell you that this function needs to again consume before it ends. So this is the reason why we had added this has drop over here. And after discussing the struct fellow, we had also discussed a little bit around generic struct. Generic struct meaning here that we do not need to specify. Uh, okay, one second, Raul. I just saw your message. After running the command aptos move init name, like I'm not getting the aptos core folder. Can you please clarify this? Uh, yeah, you are not supposed to get the aptos core folder. You are just supposed to get the sources and all of this. So basically, the aptos core folder is something that it will get from the GitHub itself. The reason that you might have seen it on my system that I have the Aptos core folder over here is because I was also trying to build certain things locally and check. So I wanted a very specific version of Aptos core, which is not relevant for us in this case. So you can just ignore that. If this is causing confusion, I will also remove this from the folder itself. So yeah, that is basically what you were discussing. Okay, coming back, generic structs here meaning that we do not need to specify what is the data type. We can just pass T1, T2 something here, and then later on we can actually just whenever we give the values, we'll just take. And yeah, this is more or less the function how we have defined it. So this is interesting because we need to have an understanding of how this generic struct syntax would look like. So yeah, this was more or less what was discussed in the last class. Okay, so in today's class we are going to start off number one with a very important concept around ownership. Okay, so if you can see my screen, I've just changed it to this new module known as owner. So here I have defined this function print x. What is it doing? What is it doing? Okay, let you folks answer. What is this function doing over here based on what we have learned in move? Can anyone share what this print x function is doing? Yeah, it is just returning the
Yes,
value.
it,
Yeah, sorry. Does anyone want to unmute and say something? Hello?
no, ma'am. Actually, it was I was saying the same.
Yeah, you're saying the same thing as Alice. Hello?
Yes, ma'am. I was saying the same thing.
Okay, okay. Gordon Manishan. Okay. So as Alice has mentioned, as Manishan has also mentioned, it's just returning the value of it. That's why I've named the function as printx as well because I just want to see the value. That's it. And here we have defined a test like account, like this is a test function, entry level function, just like how we have in other modules. And this has been called by this account. I have specified the account already as 0x1. Okay. So now the reason why this is very important for us to understand is because here we are going to actually talk about the move land concept around ownership. Okay, because in move the concept is a bit different as you see in terms of the other languages. I mentioned a little bit about this in the previous this thing as well, lecture as well. That move is not only focusing on this call by value and call by reference thing, pass by value, call pass by reference thing that you would have seen in other languages, but here we are talking about the ownership of the variables also, ownership of the variables. Okay, and everything that you see is actually something that is defined within the ownership of variables. Here in this case, it will be in the scope of you'll just see right now in the example. Okay, so here we have this function, we have defined this. I'm just gonna start uncommenting a couple of these things. Um, okay, so now let's just again, yeah, I'll just comment out this one, and I just want you to run this particular function. Let me just give you the code, and I want you to tell me what is the output that you are coming across when you're trying to run this function. Okay. So here, if I can just go over line by line for what we have written. This, as Alice has already mentioned, this is just to get the value of a, and here we have this ownership function. What we are doing here is let a 23. We're just like specifying the value for this, and then we're calling the printers function. But instead of just passing a, we have passed this copy statement, right? before it. Copy space A. Okay, and then okay, actually, I could have just done a normal this thing as well. You can try it with a normal A as well. You can just comment out this as well in your example, and then you're just printing whatever the value of C is in this case. So what is the output you are getting when you're trying to run this? I have pasted the function for your reference. I'll just wait for a minute for you folks to try this and tell me what is the output that you're getting. Okay, I can see that some people have written the answers to this. Okay. Okay, Manishan, you're getting this error module previously defined here with check if you have already defined this module. Like if you have defined some other module with the same name, or if you can share your code, I can help you debug as well. Aditya Miva has said that the answer is 23, and then Tehri has also got the answer 23. Perfect. Okay, should I wait for a minute for other folks to try, or should we change the statement and actually try something out? So now what I want you folks to do is basically comment this statement out and uncomment this out, and then try this out.
Me like
Yeah, go ahead, Manishan.
to be debug is
Yeah, can you share your code? Then I would be able to debug. Yeah, have you tried this with commenting this line in and then trying with this statement, which is the printx move a statement? What's the output that you're getting when you're trying this? Okay, how many folks are able to try this? Is there a reason why you folks are stuck? I don't see a lot of responses today. Do you want me to show you in terms of do we need to compile before Aptos move test? Yes, you need to compile before Aptos move test, but in either ways, when you run it, it will run a compile also. Address, my address is not assigned a value. Were you present in the last class, Abhishek? So I'll just show you what is happening here. So in move.toml file, I've specified a couple of addresses. This is my address that I had got from the Aptos CLI run. Uh, Without the Aptos CLI run, it would not be possible to get this address and then run this. This address that you see here, it is something that I've got from the Aptos CLI run, creating a new this thing. Should we take 5 minutes and then do this first? Like, should I show you the quick demo of the Aptos CLI also? Abhishek, can you let me know? Okay, okay. Okay, folks, let me actually do a very quick demo for that. But from the next class, I want you folks to be on up to date with the last classes, whatever we have discussed. Otherwise, it'll get difficult to keep in, like, keep in the same pace as the rest of the class. Uh, 1 second, yeah. Let me share my screen with. I've just created this repository. Can you see this? So I've just created this. You can use this Coven, by the way, for the this thing for the code base. So yeah, here is basically what you can follow. I'm gonna copy paste in our chat as well. Just follow this right now and set this up. When you run this particular line, Aptos init network development will give you an address. That is basically the new wallet that it has created for you, and you can paste that address over here in my ADDR, and that will basically allow you to then run this particular example. Okay, I'm just gonna give you like 5 minutes to just try this out and quickly set this up. Now moving back to the class. I've just have my screen share open on this. I'll just wait for a few minutes and then we can come back to the class and I can actually show the demo of this particular thing. Okay. Okay, I'll stop sharing my screen from this back to the coding screen now. I've also shared the link in the chat. So Abhishek, Caleb, Vijay, all of you can refer that and start with your CLI installation and get the address. I will have to continue on this. I will again ask you towards like after 5-10 minutes on whether your installations have been successful. But yeah, I have to proceed now and to move ahead in the class. So okay. Um, all right. Now I want you folks to try one more thing over here. If you can see, I have uncommented this particular line. C is equals to print x a colon semicolon. Can you try this out with uncommenting this line? What's the output that you get? Alice would love to know your inputs as well. Perfect. Yeah. So Tahlil, Sulekha both have mentioned that now you're getting an error. Okay. So what does this mean? So you tried it for with a lot of different statements, right? First we went for copy. Let me actually type it here only. Okay. So first we tried copy, which was working fine, right? And then we tried move, which is saying that now this particular a variable has been moved. So this is what I meant when I said that we have ownership of variables here defined within the scope. So now what we actually ended up doing by running this move space a statement was that we moved this a to actually the printx function scope. Now it's not present here within the scope of this particular function, and hence it is not accessible. Just how, like, if you try to run any operations on a right now, you would not be able to access this because in this statement you effectively passed the ownership of move away from this particular function, which is why again what we have discussed around move lang and how this term move and all of these things came up. This is something that you would not find anywhere in any other language. This You would have seen copy by value, copy by reference, all of these things. You would have seen like whenever you are creating a new variable, what it effectively does from another variable, it effectively creates a copy of that variable and then some computation happens over it, right? For example, you can say something like a is 23. In some other language, let's say a is 23, and then you can say that c is equals to a, and then c plus plus or something like that, right? And your value would be 24, right? But that is not that is not the only way to do things. Sometimes you would want to move the ownership away of certain variables when we are passing them, and that is a possibility here in move. And this is just the start of what we'll be learning in move in terms of the ownership and how things work. I also want to show you in terms of the official documentation what they have mentioned around copy and move, keywords here in move. So yeah, let me just show you that as well. One question that might be arising in your mind right now is that, hey, when this line was commented out, then this thing was just working fine. I was still able to access it. That's because C has already got the value. So when you're trying to run debug print C, you're able to run it just fine because that value has already been populated, right? But when you're trying to again after this line trying to call A, then it is not a possibility for you to now do any sort of a function over A. That is not a possibility. So this is the reason why this was working fine and you were getting 23. But now if you try to uncomment this line out because you're again calling A, you would not be able to access it. Okay. So let me now actually show you the same thing that I mentioned here over on the official docs as well. So let me know if you can see my screen. So, as mentioned here, all local variables in move can be used in two ways, either by move or copy. And copy will feel likely most familiar from other languages, new copy that we discussed, right? So with copy, the local variable can be used more than once. So they have defined how they're making copies of X and then adding stuff and all, right? So any value with the copy, like whichever value, so whatever variable here can have the copy ability, they can be copied this way. But what move ends up doing is that it takes the value out of the local variable without copying the data. And that is why after a move occurs, the local variable is unavailable, as mentioned here. So this is the way that, as mentioned, this is very different as compared to the other languages that you would see. The this infrastructure is quite different. But yeah, it has its own reasons for having certain things, yeah? And this will be more prominent when we'll actually start going deeper into understanding resources, which is now what we'll be studying. I'll just take a pause now, and I want to move back to move back to Vijay, Abhishek, Caleb. Have you been able to successfully install the CLI and get the address? And for the others who are there, is this does this make sense? What we just discussed around copy and move and how they are different things? Okay, Aptos move compile is giving you an error. Can you remove the 0x at the beginning? This is where you're stored in the move.toml file, right? Can you try with removing the 0x in the beginning? Okay. All right. So I think now that we are clear on a couple of these things, I will actually go now to the next example that we're going to study, and after that, we can actually start building a little bit around resources. That will take us some time incrementally. You'll have to build through it. And that's how I'll get there. Akhilesh is asking, is this DevNet address is connected to our wallet? How this thing works? Yes, this is basically kind of spinning up a new account. I would not say new wallet. Aptos again works a little bit differently here. It is us spinning up a new account which has a address. Yes, and we are defining the network to be DevNet, and basically whatever our pass is there, it is kind of stored in our this dot aptos kind of a folder. So all of this is there in place. So that is why it's able to work. We are essentially making a call with that particular address on the devnet. So whatever resources or changes or whatever transactions you're making, you can actually go to the Aptos scan site and use this particular address on devnet and actually see as well what is happening. Yeah, that's about it. Okay, I'll check the previous class and notion update. Go ahead and set. Okay, okay, perfect. Got it, perfect. Okay, so now that we are clear on this part, let's go back to the next example, which is going to be around a special type of object that we'll be studying, which is known as the signer object here. So I think signer is something that again is has been discussed quite some time, quite a lot in other blockchain-based languages as well, where we are talking about our addresses, or like basically we can sign transactions, and through Ethers JS or Web3 JS, it has been possible, let's say, for the EVM compatible languages, right? So in a similar manner, we'll be studying the signer object here. It is a built-in inbuilt resource type for move, and it is basically, what does a signer mean? It means like um, something that can allow the holder to act on behalf of a particular account or a particular address. So it is just that in move's case as well. So we'll kind of look a little bit into the native implementation, that you can see over here. And this is actually, like, this makes sense in the sense that we have this struct signer which has a drop. capability with the address stored over here. Okay, so the address is basically the account on whose behalf the signer can basically do whatever action, whatever transaction, blah 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 that they want to. And this drop is again associated here because they will have certain functions that will be called where they would be getting certain data. For example, here if we are trying to get a somewhere wherever it is returned, you will need this drop ability to actually run that particular function. So yeah, this is again basic signer stuff. And here they have mentioned like how would it look in terms of the syntax. Okay, so here you can see that at the rate is basically how any address definition starts over here, and this would be also in alignment. If you see our code wherever we have done hash test and the account is equals to at the rate 0x1 or 0x2 or whatever that might be. So you have to define it in a similar way. So here they have mentioned something interesting that move program can create any address value without special permission using the literals, like directly they can use it here, right? But signer values are special because they cannot be created via this. Okay, so this is again, if you even try doing things, then it would not allow you to do the same. And the reason why this is important here is like, for example, they have given this um, like this example where they're doing an assert statement where they're comparing whoever is the signer whether they are this particular address or not, and this script will abort if that is not the case. So yeah, that's the way that they have defined it. Another one or two syntactical things that we have to keep in mind here is that that always whenever you're running any sort of a function, then the signer will always have to be the first argument that comes into place. And if there are multiple signers, then again they need to be in basically that order and always on the first of compared to the other whatever parameters are there. Okay, so here they have just mentioned can have an arbitrary number of signers and all of the signer arguments must come first. Okay. So yeah, this is more or less the things that you would be requiring. Now, when we're talking about this particular signer library, so there is a signer library that's defined under here. It would be cool if I can show you the library itself. Let me pull that up. Give me a second. But yeah, what is important for us here is basically these two functions that we'll be using a lot. This is essentially whenever you are running any sort of Ethereum like functions that you will be running to like get the address, so get the signer or that kind of a thing. Similar to that, this is address of signer. So you can run this to basically get the address of signer at any point of time, or to also make a comparison whether the person running the this particular thing has the permission level to do so or not. So you can maybe check it for a whitelist as well, that whether this particular address belongs to that particular whitelist and is allowed or not, whatever that might look like for you. Okay, and then they have defined another function which is known as borrow address. Okay, so here if you see the signer object, it is returning a normal address. It's just returning a normal address. Why this is important to us is because this second function is not returning a normal address. What it is returning is ampersand address, meaning that it's returning a reference to that address. That means like this is actually returning a reference, like it's just not returning a value. Uh, Give me a second. Yeah, okay. So, and this borrow statement that you have seen over here, you will actually end up seeing a couple of more borrows as well when we start talking about resources in depth. And here they have also mentioned this particular thing. Okay, this is what will be studying in resources, so I would not pay a lot of heed to it. But essentially, this function move to is a function that is used specifically for resources to move resources or to give resources from one account to another. And here they are saying that whenever you have to move some resource, then it requires the signer's argument. So it's not possible. Like this ensures that only an authenticated user can elect to publish a resource under their address. So this is a very good way of managing any sort of permissions here. That if this move to needs to happen, then the authenticated user has the ability to decide whether they want to publish a resource under their address or not. Okay. So again, this is again a very interesting and important thing for us to understand. Okay, now let us actually try to see this STD signer standard library, because this will give us a lot of clarity on how the signer library has been defined. So just give me a second. Let me pull that up. Mm, okay, just found it. Give me a second. Let me share that. Till now, are there any doubts around this? Any sort of questions, any doubts? I'll just share my screen and show this particular piece of code. Okay. Okay, can you see my screen?
Yes.
Okay. Yes, so like move to is kind of like a transfer function. I will be talking about this in detail. That's why I've just kind of skimmed over it, because it will be what will be coming in the resources part. It is like a kind of like a transfer function for resources. Okay. So here, if you see the signer.move file, you can find it somewhere here. We're just going through this to understand what it looks like, what it means. So we have this module signer. Um, so they have mentioned this, that you can think of sign as being a struct wrapped around an address. So this is the struct thing that we discussed. We just saw that. And then borrow address, which is giving us a reference back to the address. Address of, which is just giving us an address, just the value. Okay. And we have this uh, some boolean function, which is just to check if the transaction only to check if S is a transaction signer or if A is a transaction signer address. Okay, so this is more or less how this whole signer.move file looks like. For us, we'll be using these two functions a lot, where one is this borrow address and second is this address of. Okay, so now let us actually go and see how this would look like in our code. Mm, okay, let me know if you can see my screen. So now we're going to the signer example. So here, as mentioned, signer needs data type, struct signer has drop, a address, and address of, and borrow address, which is giving us a reference. Okay, so now we have again just use this particular statement, use Aptos std signer, because it is coming from the Aptos standard library. And then we have defined this test. Here we are parsing the signer account with this particular address at 0x1. So here we are passing this, and we have given this the type signer. Okay. So now I want you to actually try doing this before I actually move on with giving you the this particular example. I want you to run this and try to tell me what happens if you try to run this particular piece of code where we are given let a signer type is equals to at the rate 0x42. What will happen if you try to run this piece of code? I'm just going to copy and paste this and give this to you here in the chat as well for you folks to try out. Yeah, perfect. So as Tel has mentioned over here, what do you end up with? It ends up with that this right side, the RHS is basically an address, right? 0x42 at the rate 0x42. But the left hand side is of invalid type because here the data type is signer, and just right now we saw the definition of signer. Signer is basically a struct which contains the address as a field. Okay, so that is why this is a correct error. So a lot of people assume in that signer means address, but signer does not mean address. Signer is an abstraction or a struct over the address. Okay, so that's why don't if you try to run something like this, it would not work. Okay, so now let's try to comment this particular line out, and let's use this. And if again you if you folks can try this out and then let me know what would the output look like. So here we are using the address of function correctly, address of, and then we are passing ampersand sn over here. Um, and here we're getting an address. And then we're trying to print that particular address. So what will happen if we'll try to run this? And there might be questions as why did we add ampersand over here? It's just the definition on how you can basically call this particular function. Yes. So you will get this unbound variable address of because uh, the what you end up with over here is not still of this signer type. So you will need to first say that this is of the signer this thing. Only then it will be able to read it because here we are not defining the bound of this variable, which is again under the signer module that we just saw, right? This signer API that we saw, this native data type, it is under that. So you cannot eliminate this. Let me show you again back over here. Uh, 1 second. Just like how we are defining our own functions and whenever we are calling them, we have to give the whole thing, right? Otherwise it will give us an error. Just like that, this would not work because we are not giving it signer address of. So it's not able to understand what is the bound of this particular address of that we are mentioning over here. Again, just copying the this module to give you the understanding of why this won't work and why you need to copy paste the entire thing, right? Because this is just like how we are doing for our own modules. Similarly, you will also have to do this when with this particular signer because it's defined under this particular module. Now, if you try running this, what is the output that you get? Okay, perfect. So now you're able to get the address and you're able to print the address just fine over here. So your signer thing is like this address of is just working fine. You're able to get the address. Now we'll actually start making use of this particular signer functions that we have defined over here because now we'll actually start off with resources in Move. And we'll create, for this first base example, we'll create our own resource. And it will be a simple collection that we will define. So yeah, before we get started on that, I do want to understand from you folks on if things are clear up till this point, and if we can move ahead with resources. Okay, I'll just wait for one or two folks to respond back as well, and then I can discuss on the same. Okay, cool. Okay, perfect, perfect. Just give me a second, folks. I'll just start off with the resources. Okay. Yeah, coming back to the class, we have this resources thing. Okay. So now that we have defined Sunner and how that looks like, the native data type and Move, we'll be talking about resources. So in the first class only, we discussed that resources are special type of structs which can't be copied or discarded. So these structs that just how we have our abilities, right? Key, store, drop, and copy. You cannot have copy and drop as abilities when you have in your particular struct. So only key can be used to store. Now, one very important property of resources is that resources are stored hello, hello.
Yes, ma'am, you're audible.
Okay, can you tell me what's the last thing you folks heard?
Suddenly, screen shelled stopped, ma'am. Like, it just started.
Just start on resources, is it?
Yes, ma'am.
Okay, okay, cool. Can you see my screen?
Yes, ma'am.
Okay, perfect. Uh, all right. So I was basically mentioning a little bit around resources, right? So resources are stored under account. So I'll show you how exactly it looks like. Give me a second. We'll just do a quick. Um, if you folks remember in the second class when we were doing the quantum network thing, I had shown you like by inputting my address and stuff on the changes and all of this in Aptos scan, and you could see certain resources over there. So that is exactly what I want to show you again today. Just give me a minute. I'll just use this particular address and try to show. I'm not able to see this over here. I'm just gonna see if I can show you over some random address then. Give me a second. Okay. Let me show you through a tab. Okay, folks, can you see my screen?
Yes, ma'am.
Okay, so this is basically my account. This is on DevNet. These are like a couple of transactions that we're doing on this account. Mostly some scripts that we have been running and stuff over here. Um, so what is interesting here is basically when we go to this resources, okay, so you can see this a type, and then there is like a definition, whatever stuff is stored over here. Uh, this is what I wanted to show you, that the resources are stored under a particular account. So, and one very important thing here is that uh, an account can store a resource of a given type, only one resource of a given type at a time. So that means that if you have this particular resource, Aptos coin, you cannot have like multiple same type of resource, which would make sense because it can just be like in terms from a logical sense, the value etc. can be modified over here itself. Like whatever changes needs to be done can be done within the struct itself. So you would not need to maintain a type, a resource of the same type over again. So at one point of time, you just need like maximum you can have at least at most you can have one resource of a particular type for a particular account. And if you try to change that, you can basically like you will run through an error that there is already a resource attached to this particular account, and this operation would not be able to go through. Okay, so this is what I wanted to show you. I'll just stop sharing the screen and we can now go back to actually creating a particular resource as well. One second. Okay, so now going to the resource file. So resource are special type of structs which can't be copied or discarded. And over here we just covered this important point. Account can hold only one resource at a time of a given type. Let me just add that. Of a given type. Okay, now coming to the resources API. Okay, this resources API is essentially what how we saw for Signer API, those two functions. So under resources, what are the different functions that have been defined? Okay, so first of all, we have this move underscore to function, and here we have this t. So here we are assuming that the resource is t, and signer is basically like as we discussed, whoever would be the one who would be doing some action on behalf of a particular address. Okay, so this particular move to statement means that we have this resources, we want to give a particular resource t to this particular signer, and if already the signer is in this case like let's say some xyz signer, let it be like at the rate 0x42 or something like that. If this particular signer already has this resource, then this will abort. This would not run. This particular function will give us some error and would not run. And we will actually see how this whole process looks. Then the next function that we have here is move underscore from. Okay, this move underscore from in a way is similar to your normal move thing that we saw in the terms of the local variable stuff, right? So it is just saying that from a particular address, we can just remove this particular resource t. So delete T from account and will abort if account doesn't have T. If that particular resource is not there, then it obviously cannot remove something which does not exist in the first place. So this is basically this definition. Then we have two important functions over here, borrow global mute and borrow global, which what it does is basically that it basically from a particular like for a particular resource T, we are just from this getting the reference to that. Just it's similar to how we did the borrow address one. One is a mutable reference that we can basically change the value of, and one is a immutable reference that we are getting. So this is just to borrow or get the I wouldn't say copy here because we are using the reference to get the actual reference of that variable. One is a mutable one and one is an immutable one. Again, we'll see how we will be using this. And the last API that we are looking at is going to be exist basically checks if a particular resource T exists at a particular address, and yes or no, like a boolean true or false would be returned. Okay, so these are the five very important APIs for resources that we'll be using a lot with whatever code we'll be writing. Okay, and one important thing that we'll be looking into is this acquires statement. I would not talk about this now. Just a little bit can just be that when a function is accessing a resource using all of these different APIs that we have mentioned, then that function must indicate that it acquires that resource. So this is just like done by moves type system. It's like a syntactical thing that you have to do, and it is done so that there are no dangling references into global storage. So dangling references means that a reference was pointing to something at some point of time, but let's say that particular content piece has now been removed from there. So that reference is now pointing like into something like empty or random. So it's just like a dangling reference. So to prevent that, they have defined that you have to use this acquire system whenever you are using a couple of these functions that they have defined. Okay, so yeah, so now that we have all of these things out of sight, now we can actually start getting into building a very simple module with a resource. Okay, so just we'll just do a normal stuff here. For today's example, what we'll be doing is we'll be building a collection. Okay, and this collection would be just like a collection of items. Okay, and here what we'll be doing is that our collection is going to be our resource. So if you see our collection over here, these are some standard statements. You have just called this module my address. You have named this collection as C or module as COLLN. And we have used signer and debug objects that you have already like seen from the standard library. But one additional thing that we're using over here is vector. Okay, so this particular like standard library has this vector thing that we are using, which is in this case is just like a list of items. Okay, so for us defining our collection as having a list of items, we are using this vector from our standard library. Okay, now, in this next thing that we have defined is just a struct item. Now, notice that item here we are not defining as a resource. Item, because it has a drop mentioned over here, this is not a resource. But if you move to the next, you can see struct collection, which has store and key. This is definitely a resource, okay? Because we are not using copy and drop over here. And in this, we have defined items as a list of items, that is a vector of items. So this is just the definition of how we have defined our struct. So yeah, before I get ahead, I just want to understand if things are clear up to this point. Uh, I'll just wait for a minute for you folks to respond. You can type in the chat if things are clear. Abhishek has asked, is item an empty struct? Yes, item is an empty struct. Yes, Akhilesh, it is difficult to remember the standard functions, which is again why I'm emphasizing that whenever I'm giving certain codes or something, rather than just copying pasting all of that, it would make a lot more sense if you um, write it all by yourself from scratch. Vector module here is basically just to define a list. Someone has asked in the chat, so I might as well just show you how the vector function, the uh, how it looks like in terms of the standard library. Give me a second. Let me just paste. So they have just defined this as a variable sized container with a lot of different functions. Like they have, it's like how we have in C++ as well, right? They have certain standard libraries they have defined, so you don't have to create the data structures yourselves and define all of the functions that can be possible over there, like size or reverse or add or push or all of these different things, right? It's all already there. So I'm actually pasting a very small snippet. Oh wait, let me actually just share my screen and show everyone as well. Give me a second. One sec. This one. Yeah, can you see my screen? So this is the standard vector that they have defined. And in this, they have defined a lot of pushback, popback, borrow, mutable, destroy, swap, all of these functions, reverse. And the initial definition is that a variable size container that can hold any type. Indexing is zero based, has some native functions, blah blah blah. So yeah, this is more or less what it contains. I'll stop sharing and move back to the code. Yeah, Akhilesh, as mentioned, it would be for the best if you folks practice writing this from scratch. It is not going to be easy to remember unless, yeah, it's just something that comes very naturally after writing a lot of this kind of code. Okay, so now we'll actually see a very small function which is talking around public fun start underscore collection where we are passing our signer, and we have this function that we discussed, this API, right? Move to, which is to transfer a particular resource. In this case, it's collection. So here we have, instead of T, mentioned collection. Account is basically our signer object here. As you can see, that's the next thing that you have to pass. And then again, you have to write the collection. So here they have also like declared that particular, like define what that collection would be. And here items, it's passed like a empty vector has been passed. So this is the way a new collection has been like defined. So this is something that you can actually start writing, and I'm going to give you just maybe we can just go over this exist function, and then we can just start first writing this part off and then move on to the other functions. So this public one exist at is where we are just giving the address and then we are getting a bull back. This is just a single line of that exist function that we saw, whether this particular collection or resource is existing at this particular address at is what we are searching. Okay, so let's just try to run this part of the module first. And can anyone help me write the test function for just this bit of code? What would the test function look like? What would the test function look like for this bit of code? Okay, someone has sent message. No, I've not given you the entire piece of code. I'm asking if someone can help me write the test function for this. We have not defined an entry function for this. So I want you to define an entry function for this, and I want you to call these two functions. One is your start collection, and one is your exist at inside that entry level function. So can you folks help write a test function for this? For reference, here is when how it looks like when it's like completely written. But I want you to write it on your own and try. Don't want to give you a hint. Otherwise, okay, so Akhilesh has given us an entry level function for writing this. Um, and public entry, blah blah blah. Start collection. Okay, Akhilesh, what is the output if you run this particular function? Can you even try and let me know what will be the output? Okay, Chakri is getting this output of debug 2, which is at this is exist at. Okay, now I want to make a modification to Akhilesh's test function, if you folks don't mind. Akhilesh, can you try adding this start collection line again after this is let is line? I just want this line to be copied again and pasted and tried. What happens if we try to run it then? What's the thing that you get? So I just want you to use the same line and paste it anywhere in the function after the first my address start collection line. Suleka, you can add this anywhere after the first my address start collection line and try this. Wait a second. Let me also try this. Can you also paste your current function? Yeah, it's working fine for me. Let me share my terminal to show you the output. So if you see, uh, this is the error code that I will get when I try to write this. If I add my address collection, start collection, after I also run the same line, meaning that if I have something like this in my code, let me copy paste and show you. So if I have something like this in my code where I have defined collection start collection, again I have defined collection start collection, then this will end up giving me this particular error which says resource already exists code 4004. Why is that the case? Because we discussed, right, that an account at maximum can have only one resource of a given type. And we have already added this particular collection resource. It has already been bound to this particular account. So when we are trying to run this again by adding another resource of the same type, which is collection in this case, then it is not allowing us to do that. And that's the reason we are getting this resource already exists for 004 error. Okay. I can see someone just tried it now. Achilles just tried this. Okay, cool. I'll just wait for a few more minutes because I want a couple of other people to try this out as well. Yes, 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 yes. Suleika, can you paste what's the error that you're getting? Are you getting the same error which is resource already exists? If you're getting some different error, paste that error, please. I see some people are using that GitHub repository. So that is that is deliberately filled with a lot of lines that need to be commented out to throw different sort of errors that can help us see the errors as well. So if someone is trying it out and if they're getting errors, then possibly uh, can't we use just start collection? And you can use that, but you will have to use the uh, you have to use the as keyword and specify in the beginning that you mean that my address collection needs to be is basically some other keyword. So you can say something like use some XYZ module ABC as Y at the beginning, and then you can use this as Y and whatever func name is there, something like this. Uh, 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 reference type. Sulekha, can you paste your entire code? Have you passed the test account correctly? Um, like you can refer to Akhilesh's example, how test account has been passed in the beginning, at the entry point. I am not sure if that is passed correctly here. And then another thing that can, what's the next one? And I also want to see what use statements you're using in the beginning. That might also could have been the reason behind possible issues. Can you send your entire piece of code, Suleika? Okay, folks. In the meantime, I'll stop sharing my terminal and move back. You can start reading through the other um, functions that are there. So next we have this add item function. Let me see if my screen is, yeah, okay. Yeah, next is this add item function. As you can see, this is acquiring that collection stuff that I mentioned. The acquires keyword is used, which, as I mentioned earlier, it is syntactically important for this keyword to be there when we are using this borrow global stuff over here. Okay. I want you to see what we are doing here. First of all, we are just getting the address from the account from our signer, right? So we are getting crossing the address of getting the address. Why are we getting this address? Because we require an address to be passed in our borrow global. If you see here, our borrow global API, it requires us to pass an address here. So our first step is to get that address, which is why I was saying this signer API would be essentially important for us. So first step here is to get that address, pass the address here, and we are getting a reference to that particular collection. And we are using borrow global mute over here when we're getting that address. And then we are doing a vector pushback. This is again defined in the vector.move file that I was showing like 15-20 minutes earlier. And here we are passing this ampersand mute collection of items. This is what is the like reference mutable this thing uh, that we are getting here. If you see this alert collection, this is what we'll be getting ampersand mute t, a borrow mutable reference. So we are just pushing back, passing this or the collection of items. And what are we passing here? We're just passing an empty item in this. So this is more or less the add item function. So here the collection is not empty. Here we are passing an empty item. So the item is still being passed. So don't get confused. It's just that the item itself is empty in nature. That is fine. But the item is getting passed. So this is the example that we can try. But before you try this out, uh, one variation of this, what I want you to try is this. So instead of using borrow global mute, I want you to use borrow global and try this particular example out. I'm just gonna copy paste this and paste it here, over here. In the meantime, I want, let me know if you folks want me to slow down a bit. If we are moving faster, let me know. We can slow things down a little bit. Because I want all of you to get to the output screen, right? Get the errors or successful runs for the test scripts. Okay, folks, just checking back in. Have you tried out this example? What are you getting? Okay, perfect. Uh, can anyone basically mention what this means basically? Mm, okay, so yeah, because what we're trying to do here is that we are trying to change this particular. Uh, we're trying to do a vector pushback on this collection, but what we are getting as a reference is an immutable reference when we are removing the borrow global mute line. So when we are getting an immutable reference and then we are trying to modify this by making a pushback, then it's not allowing us to do so. That's the reason why we are getting this particular error over here, because this is not a mutable reference to begin with. Okay, so now do you want to try this same example out, but with what we'll do is this, we'll uncomment this and comment this line. Also, we need to modify our test function again to add this particular item. So now you can add this particular item after your after the check we did for the exists. You can run another, you can add another line running this particular function, and uh, yeah, just try to run this. You would not get an output because we have not defined our size function yet, but just want you to try to run this particular function still. Also, I'll just slow down for a bit, folks, because I do not see a lot of output screens from a lot of you folks. So if things are a bit faster, then let me know. I will slow it down. Akhilesh, can you paste what your current test function is? I want you to keep the first lines for debug print ampersand is in the function as well. I think there's a spelling mistake in your code, the collection spelling. Wait. Okay, I see that a couple of people have been using the GitHub code, which is again why the reason why I was not sharing the codes this far is because if we just use that, then we would not kind of learn what is happening. So I would advise folks to slow down a little bit, otherwise, it won't make sense to do it incrementally. Akhilesh, I wanted to add to this function the add item, the current function that you have shared, the test function. I wanted to add an add item in this one. Um, Daryl, do you want to share what your output is? Uh, Aditumiva, in the last line where you have modified this, let add is equals to add item address and then a debug print over it. This is not something that you can do because this function is similar to the first line that we have written, my address collection start collection. We do not have a return type attached to this. If you see over here, we do not have a return type attached to this. If you see the exist at, you can see a boolean, which is why we did the debug print over that because there we had this thing that was returned. So we could return like a true or false value would have been returned, so we could print it off. But here we don't have a this thing defined, data type return data type defined. So when you're trying to run a debug print over that, that most certainly would cause an issue. Okay, I'll wait for a few more minutes. Uh, Taylor, do you want to share what your output looks like? Anyone wants to share what the output looks like? Because I see a couple of people have started with the size function as well. I'll just go over this once now because because you can see the output then when you run this. So we have defined the size function, which again is taking our signer and it's returning 60 U64, which is an unsigned 64 integer value. Acquires collection because we are doing a borrow global in this. Here we do not need a borrow global mute. Here using a borrow global mute is unnecessary because we just need a number back. We are not modifying anything in the collection over here. So it is getting the address just like how we did in the previous example. We are doing a borrow global, and in that we are using a vector length over the collection dot items. This vector length is again already defined in the vector dot move file, and this is what is returned to us. This last line. Um, and this is what we can basically actually um, just do a debug print over in our main test script test entry function as well. Okay, so cool. So here Tahlil has shared debug one. Tell if you have not removed that line. Where is your code? One second. Yeah, can you add Tahlil the is line as well, the exists at as well. So your output should essentially be a debug true and then a debug one as the output. Okay. I'll wait for a few minutes because I'm not sure if folks are have been able to follow along. Yeah, Thailand, do share the revised test function once. Okay, folks, checking back in. Um, how many of you have been able to write the test functions? Yes, Talil. It gives you like all of the different modules that you're running, all of the test outputs. Hi folks, I'm circling back in to check. That is something I'm not completely sure of because the way it shows up in my system is a bit different. Let me show you. Uh, 1 second. So I can see something like it shows me all of the, but it also differentiates that this is coming from this is coming from this is coming from this. Are all of the other folks able to follow? Because I can see Tehlil's output, Akhilesh, Suleika. Have you been able to follow up till this point? Haven't heard from Alice also today. Um, Chakri. Okay, cool. Let me paste the size function. This is the size function. I'm running a Aptos move test. You can specify uh, things to that as well. Again, pasting this size function for other folks as well. Okay, okay, perfect. This is good, Akhilesh. Wait for a few minutes. I also want to see Suleika's output. Ah, I see. That is interesting, Tyler. Um, hmm. Would be interesting to actually see how the CLI works when we are running these test functions. I do feel like there can be parallelization here, definitely at play, because yeah, it makes sense to that zone. Hi, folks. Can you let me know, Sulekha, if you are able to complete the example, the after adding the function of size and then getting the debug output as 1 and 2. Okay, perfect. Okay, I think we can then wrap up this class. I'll just tell you what we'll be covering in the next class. So in the next class, we'll just add a few, one or two more functions over this example that we just did today. And this is to just like practice all the resources and all of their APIs. And post that, what we will possibly take up is creating our own sort of like our own NFT sort of a collection. Yashwant, it's already there in the repository that has been shared. I'll paste it up again here. So not so we'll create our own NFT collection, sort of like not using Aptos's fungible tokens or non-fungible token standards, but like something from the very base that we'll create. So it's not exactly going to be under the scope of like how we have our own ERC standards, etc. in EVM, but something that we'll just create that will be using the resource APIs even further and more deeper. Okay, so once we are through with that, from the next class post that we can actually start using a couple of the Aptos inbuilt stuff. So the Aptos coin, fungible tokens, all of these libraries, etc. And that is when you folks can actually start posting on socials as well that you've deployed your first coin on Aptos or NFT on Aptos or whatever that can be. So yeah, that will be us like almost done with the through of like basics of what move lang would look like, and then we can actually start shipping things in Aptos. So yeah, that's a little bit around what we'll be covering in the next classes. Kiran, do you want to share anything else with them, or are we good to wrap this up?